Did you hear? 7 massive visitors are heading for Earth. Now that sounds like the start of a sci-fi blockbuster, but this is real science. By late 2025, 7 sizable comets are set to converge on the inner solar system in just 6 months. This is an event so rare that even our most advanced sky surveys, like Pan-STARRS and Atlas, have never recorded anything like it. And nestled among them is a true cosmic enigma. Comet 3, Atlas, only the third interstellar object ever detected. Its strange chemistry and vast green coma make it the ultimate wild card. The chances of something like this happening? Less than 0.5% per decade. So is this just a mind-boggling astronomical coincidence, or are we witnessing something that rewrites the rules of our cosmic neighborhood? The answers and the potential risks start right here. Every single night, a silent network of digital eyes sweeps the heavens. These are the world's automated comet hunters. Telescopes like Pan-STARRS and Atlas, perched atop remote mountains in Hawaii, Chile, and South Africa, scan nearly the entire sky, night after night. They're hunting for faint glimmers of light that would escape even the sharpest human eye. Their cameras are incredibly sensitive, capable of spotting objects far, far dimmer than Pluto. Each image they capture is a breathtaking mosaic of millions of stars and galaxies. But the real prize is movement, a single pixel drifting from one frame to the next, betraying the presence of a new comet. The process is relentless. These systems scan most of the sky every 2 to 3 nights. Their software compares each new image against a perfect digital memory of the cosmos, instantly flagging anything that has shifted its position. Once a candidate is spotted, a chain reaction kicks off. Automatic alerts are sent out, telescopes around the globe scramble for a follow-up observation, and a race begins to confirm the discovery before it vanishes back into the background noise of space. This digital vigilance has completely changed the game. Just 20 years ago, discovering a comet meant months of patient skywatching and a healthy dose of luck. Now the number of new finds has nearly doubled almost every year. Faint, distant wanderers that once slipped by us unnoticed are now cataloged, tracked, and analyzed in real time. The Minor Planet Center logs every single detection, building up a massive census of these icy travelers that grows by the hundreds. But for all this incredible power, even our best surveys rarely catch more than a couple of bright comets in a single season. The sudden clustering of 7 significant comets in late 2025 is pushing the limits of what these systems were designed to handle. Engineers and operators, who usually let the algorithms do the work, are now glued to their monitors. They're watching as the data pipeline lights up with more comet alerts than anyone ever thought possible. For the very first time, the machines are actually struggling to keep up with the sky. Before we dive deeper into this incredible celestial traffic jam, let's get a quick cheat sheet on comet terminology. It might sound complex, but it's actually pretty straightforward. First up, perihelion. This is simply a comet's closest approach to the sun. It's the point where the intense sunlight really starts to do its work, transforming a frozen nucleus into a spectacular show of gas and dust. You'll see this word in every comet forecast because that's when all the action happens. Next, let's talk distance. The solar system is huge, so astronomers use the astronomical unit, or O, as a shorthand. 1 is the distance from the Earth to the Sun, about 93 million miles, or 150 million kilometers. So if you hear a comet's perihelion is at 0.25 astronomical units, that means it's flying a quarter of the way between the Sun and Earth. For us sky watchers, the closer the comet, the better the chances for a brilliant display. Speaking of brightness, astronomers use the magnitude scale. Here's the trick. Lower numbers mean brighter objects. A magnitude of 6 is about the faintest thing most people can see with their naked eye under truly dark skies. But a magnitude of 3 or 2? That's bright enough to grab the attention of anyone stepping outside at dawn or dusk. With a bit of luck, some comets can even outshine the brightest stars in the sky. And finally, the tails. Every comet grows at least 1 tail as it nears the sun, sometimes 2. The dust tail is the broad, pale, curved one you often see in photos. It's made of tiny grains of dust pushed away by sunlight. The ion tail is different. It's straight, often blue, and is made of charged gas blown directly away from the sun by the solar wind. Think of it like a cosmic windsock for space weather. Occasionally, a powerful solar storm can even snap this tail clean off, only for it to regrow in a matter of hours. These tail disconnection events are rare, but with so many comets crowding the inner solar system in 2025, we might get to see more than one happen live on camera. Keep these basics in mind, and you will be able to decode every headline and sky chart as these 7 visitors make their grand entrance. Statisticians who work with comet survey data have a little joke. The universe is usually pretty stingy with its surprises. In a typical 6-month period, the odds say we should expect to see 2, maybe 3 comets bright enough for a backyard telescope. The rest are just faint, distant blips destined for the archives. But late 2025 is throwing all of those expectations right out the window. 7 significant comets, all reaching their closest point to the Sun within a single half-year, have set off alarm bells in every computer simulation run by comet experts. The numbers are stark. Over the last decade, our digital surveys have gotten incredibly good at finding faint comets. But even with our best technology, simulations show that a cluster of 7 bright ones in one season is a massive statistical outlier. When researchers feed the real-world data, our survey sensitivity and our best estimates of the comet population into their models, the average result is just 2 or 3 comets per 6-month window. The chance of seeing 7? Less than 0.5%. Some simulations even spit out odds closer to 1 in 1,000 years for a group this bright. This extreme rarity isn't just because we have better cameras or smarter software. The appearance of bright comets is governed by the fundamental physics of their orbits and the random chance of when they get nudged towards the Sun from the distant Oort cloud. Better survey tech helps us find more faint wanderers, but it doesn't just conjure up a group of 7 major visitors out of thin air. The 2025 lineup stands apart from anything we've ever logged in the digital era, and even searching through old photographic records struggles to find a match. For data scientists, this is the kind of anomaly that demands a second, third, and fourth look. Are we seeing the aftershock of a distant collision that sent a swarm of comets our way? A strange fluke in the dynamics of the Oort cloud? Or is it just a cosmic coincidence so incredibly rare it almost feels scripted? Whatever the cause, the numbers are crystal clear. 2025's comet traffic jam is as close to winning the celestial lottery as modern astronomy has ever come. Some comets are content to just slip quietly through the solar system, but this incoming group is anything but quiet. Have you ever looked up at the night sky, hoping to see something truly spectacular? Something beyond the familiar stars and planets? Well, get ready, because 2025 is shaping up to be an absolutely phenomenal year for skywatchers. We're talking about comets, those beautiful, ghostly visitors from the outer solar system. And we're expecting not 1, not 2, but 7 of them to grace our skies. Now, not every comet is a showstopper. Some are like quiet, shy guests at a cosmic party, passing by almost unnoticed. Their faint glow gets a little lost against the vast backdrop of stars. In 2025, 2 of our visitors fall into this more subtle category. See 2022 Pan-STARRS and 240P NEAT. Let's start with Pan-STARRS. It reaches its closest point to the Sun, or perihelion, on July 31st. But close is a relative term here. It'll be about 3.82 astronomical units from the Sun. To put that in perspective, that's way beyond the orbit of Mars, closer to Jupiter's neighborhood. At that vast distance, the sunlight is pretty weak, so it barely tickles the comet's icy surface. The result will be a very modest coma, that fuzzy, glowing head of the comet visible only through powerful telescopes with sensitive cameras. For most of us with backyard telescopes, we might only see a dim, fuzzy smudge, even on the clearest of nights. Then we have 240P NEAT. This one is a returning traveler, a periodic comet that we've seen before. It makes its pass on December 19th, coming within 2.12 astronomical units of the Sun. While that's closer than Pan-STARRS, it's still more than twice as far from the Sun as our own planet Earth, and that distance really affects its brightness. Every time it returns, it puts on a low-key performance, a faint encore for those dedicated enough to hunt for it in the cold winter sky. So who gets excited about these faint comets? Well, they have a very dedicated fan base. This is the realm of serious amateur astronomers, the folks who spend hours logging observations, meticulously stacking images to bring out faint details, and sharing their findings in online forums. Their patience and dedication are what fill in the data for these quieter visitors, ensuring that every single comet, no matter how faint, gets its moment in the scientific record. These telescopic whispers remind us that the 2025 lineup has a full spectrum of celestial sights. They're the opening act, setting the stage for the brighter, more dramatic arrivals that are still to come. But if you're someone who's dreamed of seeing a comet bright enough to rival the stars, a celestial spectacle you won't need a high-tech telescope to enjoy, then late 2025 is your time. 3 of our 7 visitors, Swan, Atlas K1, and Lemon, are gearing up to be true crowd pleasers. Each one brings its own promise of a spectacular show. First up is Comet Swan, officially known as C2025R2. Mark your calendars for October 21st, when it makes its closest approach to Earth, passing just a quarter of an astronomical unit away. That's about 37 million kilometers close enough for the solar wind to really interact with it, whipping its gas and dust into a long, dramatic tail. Predictions for its brightness are incredibly exciting. Models suggest Swan could reach a magnitude of 2 or even 3. That's bright enough to be seen with the naked eye, turning Comet watching from a niche hobby into a neighborhood event. Imagine stepping outside at dawn and seeing this beautiful celestial object hanging in the sky. Just a few weeks later, another heavyweight contender barrels in, Comet ATLAS-K1. It reaches its perihelion on October 8th, and it's going deep into the solar system, well inside the orbit of Mercury. The intense sunlight at that proximity, just 0.33 astronomical units, is expected to kick its activity into overdrive. We're talking powerful jets of gas and dust erupting from its surface. Astronomers will be watching for a sprawling, complex tail and the kind of unpredictable outbursts that make for stunning, headline-grabbing photographs. Comets are notoriously unpredictable, and this one could be a real wild card. And the celestial parade doesn't stop there. Rounding out our trio of potential headliners is Comet Lemon, or C2025S6. Its closest pass is on November 8th, at just over half an astronomical unit from the Sun. Current forecasts suggest it could brighten to magnitude 4, maybe even 3.5. That would make it easily visible at dusk, a perfect target for anyone with a pair of binoculars, or even just keen eyes in a dark location. 3 bright comets in just a matter of weeks. It's an astronomer's dream. So what makes these comets different from their fainter cousins? It all comes down to a cosmic recipe of size, composition, and trajectory. A larger nucleus means more ice and rock to vaporize. A composition rich in volatile materials, like frozen carbon monoxide, means it will start putting on a show even when it's far from the Sun. But the real key is the trajectory. A path that takes a comet close to both the Sun and the Earth is the perfect combination for a spectacular display. The Sun's heat provides the engine, and a close pass to Earth gives us a front-row seat. Swan, Atlas K1, and Lemon all seem to have this winning combination, promising a celestial fireworks display unlike anything we've seen in years. Now, let's talk about the real wild card of 2025. The one comet that has the entire astronomical community buzzing with anticipation. Comet Suckinshan Atlas, or C2023A3. This isn't just another bright comet. This could be the one. The one we'll be talking about for decades. This could be a true great comet. Discovered in early 2023, its orbital calculations immediately set it apart. Suckinshan Atlas is on a path that will bring it incredibly close to the Sun, just 0.39 astronomical units on September 28, 2025. Then, just 2 weeks later, on October 13th, it will make a remarkably close flyby of Earth at about 0.47 astronomical units. This is the perfect 1-2 punch for creating a jaw-dropping spectacle. The intense solar heating will cause massive amounts of ice and dust to erupt from its surface, creating an enormous, brilliant coma. And because of our viewing angle right after its close pass to the Sun, we could witness a phenomenon called forward scattering. This is where sunlight shines through the comet's dust tail from behind, making it appear spectacularly bright, potentially reaching a magnitude of 0 or even negative numbers. That's as bright as the brightest stars in the sky like Vega or Sirius. Some optimistic predictions even suggest it could rival the planet Venus. Imagine that, a fuzzy star with a long sweeping tail, visible to everyone on Earth, even from light-polluted cities. It has the potential to stretch across a huge portion of the sky. But, and this is a big but, we have to remember that comets are notoriously unpredictable. They've been called cosmic cats for a reason. They have tails and they do whatever they want. There's always a chance a comet could fizzle out, or even break apart as it gets close to the Sun. We've seen it happen before. So, while the potential is astronomical, we need to approach it with a healthy dose of cautious optimism. We'll be watching its development every step of the way. So how can you prepare for this incredible year of comets? For the fainter ones like Pan-STARRS and MEET, you'll want to connect with a local astronomy club. They have the right equipment and the expertise to help you hunt down these elusive targets. For the brighter comets like Swan Atlas K1 and Lemon, a good pair of binoculars will be your best friend. They'll reveal the comet's fuzzy head and the beginning of its tail. Find a spot away from city lights. Let your eyes adjust to the darkness for about 20 minutes, and look in the direction provided by sky charts or astronomy apps. And for the potential great comet Succean Atlas? If it lives up to the hype, all you'll need are your own two eyes. It could be a truly global event, a shared moment of wonder for all of humanity. 2025 is shaping up to be a historic year for skywatching. From the quiet whispers in the deep dark to a potential roar that could light up our skies, there's something for everyone. So get your calendars marked, your binoculars ready, and prepare to look up. You won't want to miss this. Have you ever dreamt of seeing a comet so bright it outshines the stars? Well, get ready, because 2025 is shaping up to be the year of the comets. We're not talking about just one faint smudge in the sky. We're talking about a spectacular lineup of at least 7 comets, all parading through our inner solar system in a 6-month cosmic fireworks show. This isn't just a once-in-a-decade event. It's a once-in-a-generation opportunity for scientists and skywatchers alike. And the star of the show? An interstellar visitor from another star system, a comet named 3I Atlas, making its first and only appearance in our cosmic neighborhood. But it's not alone. It's joined by a cast of other brilliant comets, each with its own story, creating a celestial traffic jam that promises to fill our skies with wonder. From backyard binoculars to the most powerful space telescopes, everyone will have a front row seat. So grab your calendars and mark the dates, because you won't want to miss a moment of this extraordinary celestial event. Let's meet the key players in this cosmic drama. We have Comet Swan, a potential naked-eye superstar for the Northern Hemisphere. Then there's Comet Atlas K1, set to put on a dazzling display as it orbits close to the Sun. And don't forget Comet Lemon, a classic beauty expected to grace our evening skies. Each of these comets holds the potential for something truly rare, a sight so brilliant you won't need any special equipment to witness the spectacle. But the excitement isn't limited to what we can see from our backyards. Some comets like 414P Stereo will be almost invisible to us on Earth, hidden in the sun's glare. This is where our fleet of sun-watching spacecraft, like SOHO and Stereo, come into play. They're specialized cameras designed to monitor solar storms. Will capture these comets as bright streaks against the sun's corona, revealing details about their activity that we could never see from the ground. With so many celestial visitors arriving at once, it's creating a logistical puzzle for scientists at NASA and ESA. The October sky will be incredibly crowded, not just with comets, but with competing scientific priorities. Do they focus on the dramatic tales of Comet Swan and Atlas K1? Or do they dedicate precious instrument time to the interstellar newcomer, 3I Atlas, during its fleeting passage through our solar system? Each spacecraft has a limited field of view and can only point at one target at a time, forcing scientists to make some very tough choices. Will they choose to study the rare interstellar chemistry of 3I Atlas, or chase the evolving tails of the other comets as they react to powerful solar storms? These aren't just pretty pictures, they're crucial data. Heliospheric imagers will be watching in real time for tail disconnection events. The incredible moment, a solar eruption literally severs a comet's tail, giving us a direct look at how the sun's magnetic field sculpts the space weather that fills our solar system. This cosmic convoy is all happening in an incredibly tight time frame. From late July through December 2025, the inner solar system will transform into a celestial superhighway. It all starts in July with the distant pass of Comet Pan-STARRS. Then the pace accelerates. By September, Comet Swan is closing in, followed by 414P Stereo, which will sneak past the Sun as our spacecraft watch. October is when things get really crowded. Atlas K1 will dive towards the Sun, outgassing furiously inside Mercury's orbit. Just days later, the interstellar outlier 3I Atlas will fly past Mars, its coma swelling to an enormous size. Comet Lemon follows in November, drifting into our evening skies with the promise of naked-eye brightness. And finally, in December, 240P NEAT provides a quiet encore to this incredible season. When you look at the timeline, it feels less like a random series of events and more like a perfectly choreographed cosmic ballet. The challenge won't be finding a comet. It will be keeping track of which one you're looking at. One of the most breathtaking features of these comets will be their magnificent tails. Each comet actually has two distinct tails, and they tell different stories. First, there's the dust tail. This is the broad, curved, and gently glowing tail that most people picture. It's made of tiny dust particles pushed away from the comet by the pressure of sunlight itself. These particles scatter sunlight, creating a pale, sometimes golden fan that follows the curve of the comet's orbit like a luminous wake. Then you have the ion tail. This one is a straight, narrow, and often electric blue blade. It's formed when the sun's ultraviolet light energizes gas molecules in the comet's coma, turning them into ions. The solar wind, a constant stream of charged particles from the sun, then grabs these ions and blasts them straight away from the sun, regardless of the comet's direction. So for sky watchers, the visual cues are clear. The dust tail is wide, soft, and yellowish, while the ion tail is thin, straight, and blue. Both are beautiful, and both are at the mercy of the sun. Speaking of the sun, its powerful storms can do more than just create beautiful auroras here on Earth. They can wreak havoc on a comet's tail. When a massive blast of energy, called a coronal mass ejection or CME, erupts from the sun, it drags the sun's magnetic field with it across the solar system. If a comet is in the path of one of these storms, the results can be spectacular. The comet's straight blue ion tail can be completely severed in a matter of minutes. One moment, the tail stretches for millions of kilometers. The next, it's been sliced clean off, left to drift in space while the comet starts growing a new one. In 2007, a NASA spacecraft captured this happening to Comet Inc., and the footage was incredible. Scientists call this phenomenon magnetic reconnection. With 7 comets crowding the sky in late 2025, the chances of seeing another one of these tail-snapping events live are higher than ever. It's a dramatic real-time reminder of the sun's immense power. So why is 2025 predicted to be such an active year for these disconnection events? It all comes down to geometry. Most of these comets will be traveling along the ecliptic plane, the same flat disk where Earth and the other planets orbit. This shared celestial highway puts them directly in the firing line for solar storms. Think of it like a cosmic bowling alley. With so many pins lined up, the chances of a ball ACME scoring a direct hit go way up. Forecast models show that while a single bright comet might have a 10 to 20% chance of a tail disconnection in a typical year, having 7 of them stacked along similar orbits multiplies those odds significantly. We could see several of these events, maybe even 2 or more in the same week. For us on the ground, it means every time a CME erupts from the sun, it's a roll of the dice. We'll be watching to see if the timing lines up, giving us a rare chance to see the sun's invisible hand at work, written in streaks of blue across our night sky. Now let's talk about the interstellar visitor. 3I Atlas. Data from the Hubble and James Webb Space Telescopes has revealed something truly mind-boggling. The glowing cloud of gas and dust surrounding this comet, its coma, has been measured at nearly 700,000 kilometers across. That's not a typo. The coma of this single comet is almost half the diameter of our Sun and more than 50 times wider than the planet Jupiter. It's a gigantic diffuse green sphere that completely dwarfs the tiny, rocky nucleus hidden at its heart. To put this in perspective, if you placed this comet's coma where the moon is, it would fill a huge portion of our night sky. Its sheer scale is hard to comprehend, a testament to the fact that this object has traveled for millions, perhaps billions, of years through the cold of interstellar space, accumulating ices that are now vaporizing as it gets its first and only dose of our sun's warmth. The truly extraordinary thing about 3I Atlas is its origin. It doesn't belong to our solar system. Unlike the other comets, which are on elliptical orbits that bring them back around the sun, 3I Atlas is on a hyperbolic trajectory. That's a fancy way of saying it's a one-way trip. It's hurtling through our system at an incredible speed and will swing past the sun just once before being flung back out into interstellar space, never to return. This is only the 3rd interstellar object we've ever detected, and it's the first one we've had advance notice for. It's a messenger from another star system, carrying chemical clues about the building blocks of planets far beyond our own. For scientists, this is an unprecedented opportunity to study a pristine piece of another part of the galaxy up close, a true alien visitor in our own backyard. The 2025 comet season is more than just a series of beautiful events. It's a global scientific collaboration. From professional observatories on remote mountaintops to amateur astronomers in their backyards, and from our most advanced space telescopes to our fleet of sun-watching spacecraft, everyone is working together. This coordinated network ensures that every angle is covered. Ground-based telescopes provide the wide-field views, tracking the comets as they move across our night sky. Spacecraft provide the close-ups, studying the comets' chemistry and their interactions with the solar wind in ways we can't see from Earth. This combined effort allows us to build a complete 3D picture of these visitors, ensuring that no discovery slips by unstudied. The data collected will keep scientists busy for years, rewriting our understanding of comets, space weather, and even the formation of other solar systems. This is citizen science and professional astronomy coming together on a massive scale. So whether you're a seasoned astronomer or just someone who loves to look up at the stars, 2025 is your year. Don't miss this spectacular, once-in-a-generation show. Did you know there's a comet out there so big it could swallow planets whole? It's called 3I Atlas, and it's not just big, it's alive. As sunlight hits its surface, jets of gas and dust erupt with incredible force. Imagine a bowling ball's worth of fine dust being shot into space every single second. And for larger chunks, it's up to 60 kilograms per second. These jets create a breathtaking spectacle, carving out fans and streamers that change almost hour by hour as the comet spins. It's like a living, breathing structure, constantly being reshaped by the sun. Astronomers using the Gemini South and Palomar observatories have been tracking these changes, revealing a comet that is anything, but still. The jets flicker and pulse, tracing arcs that stretch for hundreds of thousands of kilometers. At over 150 million kilometers from the sun, 3I Atlas is already putting on a show that rivals the most active comets we've ever seen. For astronomers, it's a golden opportunity to study a comet's mechanics in real time, piece by piece. But the biggest question they're asking is, what is this cosmic visitor actually made of? Well, get ready for a twist. Spectroscopists using the James Webb Space Telescope have discovered that 3I Atlas is a total rule breaker. Most comets are all about water, but this one? It's flooded with carbon dioxide. For every 1 molecule of water, there are 8 molecules of CO2. That's a record-breaking ratio. Instead of the usual water vapor creating a classic glowing tail, CO2 jets are erupting from the surface, painting its coma a ghostly green and sparking a huge debate among scientists. Was this comet born in an ultra-frigid region of its home star system, far beyond where water typically freezes? Or is a thick, insulating crust hiding vast reserves of water ice, just waiting for the right moment to burst free? The jury is still out, but this isn't just some academic puzzle. If 3I Atlas is shedding CO2-rich dust, the particles it leaves behind could be unlike anything we've ever encountered. And here's where it gets really exciting. With all this cosmic action, it's no surprise that rumors are flying faster than the comets themselves. Social media is buzzing with dramatic claims and doomsday predictions about the 2025 Comet Parade. But let's look at what the actual data says. Every single comet in the 2025 lineup is on a well-mapped path, calculated and rechecked by professional astronomers worldwide. None of them, not one, comes close to hitting Earth. The closest flyby will be Comet Swan, at about 37 million kilometers away. That's more than 90 times the distance to the Moon. The others will pass even farther out, their paths guided by the simple, predictable laws of gravity. Expert panels from NASA and the European Space Agency have reviewed all the orbits. Their conclusion is unanimous. There is zero physical way for these comets to trigger earthquakes, storms, or any other disaster you might see trending online. These are icy leftovers from the dawn of solar systems, not cosmic wrecking balls. The only thing they're going to influence is the number of us looking up at the sky in awe. The message is simple. This is a spectacular celestial show, not a threat. It's a time for wonder, not worry. So how can you see these amazing visitors for yourself? Let's get into the when and where. Mark your calendar for October 21st. Just before sunrise, step outside and look to the east. Comet Swan will be making its closest approach to Earth. If you have clear, dark skies, you won't even need a telescope. Predictions suggest it could shine as brightly as the stars in the Big Dipper, with a tail stretching across a good chunk of the sky. It's a rare treat for the early birds. Then, a few weeks later, the evening sky gets its turn. From November 6th through the 12th, look to the west right after sunset to spot Comet Lemon. This is your classic evening comet, No alarm clock needed. Just find a spot with an open view. It could be bright enough to see with the naked eye in a rural area. If you're in a city, a pair of binoculars will help you spot its fuzzy glow. The best time to look is about 30 to 60 minutes after the sun goes down. For both comets, a simple pair of binoculars will make a huge difference, revealing the coma's soft glow and the faint beginnings of a tail. A small telescope will show even more detail, but honestly, you don't need fancy gear. Just grab a star map app, dress for the weather, and give your eyes a few minutes to adjust to the dark. The most important thing is patience. The view changes nightly, so this is your personal invitation to join in on one of the greatest sky shows in years. So, why are so many comets showing up at once? This cluster of arrivals has no precedent in over a century of recorded data. While we know the dust from 3I Atlas might cross our orbit in 2026 without any risk, the reason for this comet parade is still a mystery. Our current models can't fully explain this sudden spike in activity. It seems to be a rare convergence of random chance and our own improved ability to detect these objects. As 2025 and 2026 unfold, we're not just witnessing a statistical anomaly. We're part of a unique opportunity for scientific discovery, documenting a truly historic event in real time. Thank you so much for joining me on this cosmic journey. If you enjoyed this and want to stay updated on all things space, make sure to hit that like button and subscribe for more adventures. Until next time, keep looking up.